Joined now by Scott Higginbotham, who is the payload manager for STS-123. And Scott, we're going to, knowing that you've spent a great deal of time with these payloads that have been with us here over the last, golly, how long has it been since these arrived?
Well, we've been processing the hardware for a little over a year, but the planning for this mission has been in the works for well over a decade.
Well, we're going to look at some tape right now, and you can tell us some of what we've done to get the Kibo logistics module and the Dexter ready to fly.
Very good. The Japanese experiment logistics module pressurized section arrived via ship from Japan on the 12th of March of last year. And here it's being lifted from the ship and placed on a flatbed truck. That took place on the 13th of March. And then it was taken overland to the space station processing facility. The trip from Japan by ship took over 30 days and came across the entire Pacific and through the Panama Canal to Florida. The hardware spent about 7.5 months being processed in our facility. And here is a view of the flight crew that came down numerous times during the flow, but in this particular case in mid-October to do their final evaluation of the flight hardware. The hatch of the PS was closed for flight on the 15th of November after the 8 racks were installed. There are 5 systems racks, 2 payload racks, and 1 stowage rack inside the PS. The PS was lifted on the 27th of November and moved down to another work stand where we could weigh the element and perform our final joint NASA and JAXA activities, getting the hardware ready to fly. And here you can see it flying over its big sister, the PM module, which will fly next with us on the 1J flight, STS-124. The PS module fully outfitted weighs about 19,000 pounds. On orbit, it will be pre-positioning racks for use in the PM module. The SPDM, or Dexter, arrived from Canada on the 19th of June of last year, spent a few months processing offline, and then on September 25th, we started the hoist of the 3 major components of SPDM onto the Space Lab pallet. SPDM will be a robot on orbit attached to the station robotic arm to replace spare parts on the outside of the station. And like with the PS, the crew came down and performed some very close evaluation of SPDM, particularly because during this mission they will be assembling it on orbit. And this is a view of the installation of one of our many sidewall payloads flying with us on this mission. This is the MISSI 6 experiment. It has 2 sample exposure cases called PECs, or passive experiment containers, and they are being installed under the sidewall of Endeavour's payload bay. On this mission we have 7 different items, 3 U.S. spare parts, and 4 payload components. Finally, after all the work was done, the PS module was lifted for installation into our transportation canister on the 8th of February of this year. This was in anticipation of delivery out to the launch pad. For my parents back in Missouri, the guy in the red shirt there at the bottom, that's me. And here is the element being rotated before it's installed into the canister. You'll notice there are some shields missing from the side of the module. They were installed after the element was put down into the canister. Next, we're going to see the lift of the Space Lab pallet and SPDM atop it. This occurred on the 11th of February of this year. Sadly, for me at least, this is the last planned flight of a Space Lab pallet. This hardware dates back to the 80s when we flew a number of Space Lab missions. It was built by the Europeans for our use. After both elements were in the canister was rotated to vertical, and here you see on the 15th of February the canister departing for Pad A. We have a specialized facility here at KSC where we can rotate these canisters from horizontal to vertical and back the other way. The trip to the pad takes about 3 hours. We go very slowly to avoid inducing any vibrations into the spacecraft. Some beautiful footage here of our rollout right at sunset. And here the canister is finally arriving at the launch pad. The canister is hoisted up into the rotating service structure. The doors of the canister are then opened, and the payload is extracted using a 5-story tall gantry called the Payload ground handling mechanism. It picks both of the elements up out of the canister and pulls them back into the rotating service structure. The canister doors are then closed, it's lowered, and it is transported away. Once the shuttle arrives at the pad, the rotating service structure comes back around, and that Payload ground handling mechanism installs the payloads into the orbiter, which is what you see here. Here's the last view of the PS and the last view of SPDM taken on the 18th of February. And finally, on the 19th of February, the payload bay doors of Endeavour were closed for flight, marking the conclusion of our ground processing campaign for both elements.
There's probably a fairly simple answer to this, but why didn't we launch everything with Kibo together?
Well, Kibo is a very large assembly of hardware, too large, in fact, to fly on any one given shuttle mission. So the hardware is being distributed over 3 different flights. We have this mission that we're going to launch here in the morning. We have the 1J mission that will fly in late May. And then we have the 2JA mission, which will be flying next spring. And those 3 flights will be carrying up the 5 major components that make up Kibo. The first launching on this mission, the PS. On the second mission, we have the large pressurized module, the largest pressurized module of the ISS. And on the front of it is their robotic manipulator system, or RMS. And then on the final flight, we have 2 exposed facilities. One, the exposed facility, and the second, the experiment logistics module exposed section. And together, they all make up Kibo, which means hope in Japanese.